So welcome to this first panel, Open Models in Planning, Policy and Institutions. This panel intends to explore an important question for the open energy modeling community. What does it take for open models to move from research artifacts into real-world policy and planning decisions? So we have four panelists. Luciana Marques from the Open Energy Transition, Samuel Dotson from the Union of Concerned Scientists, Simon Langlois-Bertrand, Institut de l'Énergie Trottier, and Edouard from Energy Modeling Hub. So we can give them first a round of applause. Thank you for being here. So our first panelist, Luciana, will speak about rethinking Europe energy planning. Do you have a presentation?
Yes.
Okay. So,
yeah, thank you. How does that work? I just
you can
press.
move with the pointer, the green one, the big one.
Then I go to the next one.
Yeah.
Yeah, great. Thank you. Good morning, everyone. So I'm Luciana from OET, and I'm going to talk to you about the planning process and how we can use open source in real-life planning process in Europe. The planning process in Europe is a bit very complex, interdependent. We have many actors involved. We have transmission system operators, regulators from different countries involved. And it's done in multiple different steps. Like we first have like the climate targets being defined, and then network development and infrastructure decisions, followed by security of supply studies and adequacy assessments. And finally, we now have like flexibility needs assessments as well. And you're going to see in my presentation that open source models are becoming really a shared analytical foundation across this different planning process and these planning studies. The first example I bring to you is work we did together with the Walloon government in Belgium. So here we really applied open source to create value, even in partially confidential process. So there we use a combination between TIMES model and PIPESA EUR model. So the TIMES for more like the long-term planning with the endogenous modeling of demand. And that's like a partially proprietary data, while with the PIPESA EUR, we were able to have a more detailed capacity expansion model. So here we were able to combine these two. We were able to also enable sector coupling with high spatial and temporal resolution with the PIPESA Walloon model, and we could balance the confidentiality with the transparency. The second example I have to you is on the network development part. So we have developed an open TYNDP version. So the TYNDP is the 10-year development plan, network development plan, and it guides Europe's multi-billion European grid investments. So here you really need like a transparent process. And with the open TYNDP, we're able to like enable like a broader assessment of the investment options and really engage with the stakeholders and have a more like a collaboration between the different stakeholders. And the last example I have to show you is that we also using open methodologies to shape the future of flexibility planning. So now Europe is transition a bit beyond just adequacy. So instead of just looking at loss of load and security of supply, we now starting to study also the flexibility needs and how can we transition to a more renewable system. And here then the biggest request from the European, in general, the European government, was to have something open source, so the process could be transparent and built together with different stakeholders. So like many of the different studies in Europe, you have like the national versions of the studies and the European-wide versions of the studies. And for the flexibility is not different. So the member states, they do their national versions of the study, and we also have this EU-wide version of the study, and that's where OET has been working together with the European regulator to put together a model of fully open source to perform the study and to have fully transparent process. So here, for now, the model is still confidential, but I invite you to follow us and stay tuned, because this EU-wide flexibility needs assessment model will eventually become an open source model, and we're planning to release it as an open source model. So to close, the Open Energy Plan is not and not anymore a future vision. It is already happening. With the examples I brought to you, you have open source models that can support the entire planning chain from the definition of the climate targets, long-term climate targets like the net zero by 2050, to really specific assessments like the flexibility needs assessments, the last version that I showed to you, the last study I showed to you. These open source planning models, they can enable the transparency, trust, and better decision taking via an open collaboration between the multiple stakeholders, like the OpenTY-NDP example that I brought. And the existing open source tools can be easily adapted to specific contexts. So customization are easy and affordable, like the flexibility assessment study that I showed by the end of the presentation. So yeah, I think Canada has an opportunity to build open by design planning process, because in Europe, I mean, it was first very proprietary, and now it transitioned to a more open source context. And I guess here, this can be like a more open by design process. Thank you very much. That's it from my side. And I guess we're going to have time for questions after the presentations, right? Yeah, thank you.
Thank you, Luciana. So, second panelist, Samuel, will present a PIPSA-based analysis to support policy design in Illinois.
Okay. Do I need to hit start?
Yeah, you can.
Do I need to hit this button to start the timer? Oh, it's already going. All right.
Already started.
Hi, thank you so much. I'm Sam Dotson from the Union of Concerned Scientists. The mission of UCS is to put rigorous science into policy action. And I don't have any slides for you today, but I do have a story. And the story is, it started in at the end of 2023. The Illinois Power Agency, for those of you who don't know, Illinois is the home of Chicago. It's a big city in the U.S. The Illinois Power Agency was commissioned by state legislators to do a policy study on the impact of a gigawatt of battery storage and very specific numbers. And they conducted this study. They evaluated the impact of these mandated targets. But there were two problems with this approach. First is that these targets were not informed by any kind of modeling. They just sort of fell out of discussions and debate in the legislature. And the second problem, of course, is that all of these studies that were conducted were done with proprietary models, Plexos, Aurora, Mars, these types of models that we can't assess the outputs of, even if we had the adequate input data. So UCS adopted a different approach that we eventually used for testimony in future legislative sessions, and we wanted to just ask the question and answer it: what is the appropriate amount of battery storage for Illinois given its long-term climate goals? And so to do this, we used the PIPSA framework to build a model for Illinois. And it took us about 6 months from planning or initiating the project to publication. And that includes all of the time it took for stakeholder engagement, getting scenarios defined, and getting people comfortable with the results that we were going to share. And then after that, we published, and we had a really good, there was a really good moment to publish these results, because the next legislative session was going to, again, take on this policy question of how much storage Illinois needed to set a target for the state. And we had enough time ahead of that to disseminate, diffuse, share our results and get them socialized in the media and to help build consensus. And ultimately, through the next 6 to 9 months after those results were published, we had several workshops and sessions to discuss the results, explain the modeling that was done, both to the public and to policymakers. And the number that was eventually adopted was the number that approximately came out of the modeling. It was a much rounder number than what the model told us. But there was a direct line between the modeling that we did, asking the question, how much storage is needed, and the ultimate policy target that was adopted at the end of 2025. And there are, I think, 3 ingredients that made this successful. First was that we had a simple modeling approach. We kept it simple. We didn't have lots of complex interactions with other states and markets. We just focused on Illinois, and we had a very narrow research question. How much storage is needed, given Illinois' policy goals? The other thing we had was timing. Timing we found was super important, both because and it showed up in 2 ways. First, it showed up as policy relevance, right? We asked a question that was important given the current policy environment. And second, the timing gave us enough runway to socialize the results of the study with legislators and with public testimony to generate consensus. And I think that is pretty much the story, and I'm happy to answer more questions about this in the following session.
Merci Samuel. Je vois des gens qui sont assis, qui sont debout. Il y a des chaises encore dans la table devant. There are seats available in the first table if you want to use them. So we now turn to the third panelist, Simon, that will explore modeling as a strategic tool for research with insights from a net zero pathway analysis. Simon.
Bonjour. Thank you. Good morning. So at the Trottier Energy Institute, we do work that uses modeling to better understand and anticipate net zero trajectories or decarbonization trajectories more generally, and try to translate that into policy recommendations to realize them. And what I wanted to talk about in this short time is the fact that modeling for us delivers strategic value along 4 dimensions at least. The first one being obvious. So after a while, there's a convergence in some of the results, some of the orders of magnitude, and it gives you general information about the main elements of pathways, right? So how much ballpark electricity do you need to decarbonize? What's the cost of deploying a supply distribution infrastructure for hydrogen in a given region compared to other options, and so on and so on. But I'd like to highlight and focus on 3 other dimensions. One is that we use the modeling as a diagnostic instrument, trying to reveal where policy leverage may be highest, right? So for instance, when you get results, you get detailed results, and then you delve into what the trajectory means in terms of concrete elements to be deployed, removed, or transformed, right? So you look at transport, you don't care that much about the general energy mix in the results. You look at different segments, and you notice that the energy mix is different in the scenarios, which is hardly surprising. But then you look even closer, and you notice things like off-road transport becoming the main source of emissions across basically any scenario by 2050 in Canada. So little attention to this, so you can ask the question, why is that? So is it just because there wasn't that much policy on it before? Is it because it's too costly or technically infeasible? And then you dig deeper and you realize that you can still find strategic links to be made in elaborating strategies to decarbonize a service for these sectors, right? So it's a short list of equipment, so large-scale special use vehicles for construction, for instance, may yield some elements that you can combine with a strategy on forestry or mining and so on. Another dimension in the strategic value of modeling and what we do is that it allows to systematically surface gaps in current strategies or research, right? How to prioritize research to be done. On the longer term, to state the obvious, there's a lot more uncertainty, and modeling in this context, as we understand it, is not necessarily about eliminating it or even reducing it. It's about mapping it out better, understanding the contours of that uncertainty much better, and inform choices that may need to be made today, right? So the results may force you to think about what needs to happen in order for a result to be realized. So part of this information is about policy. Part of it is about the limitation of the pathway itself, right? So after a while, you see a lot more electricity, but then in a country like Canada, that also means that you go from 2 to 10 provinces that will be winter peaking, and so that raises a lot of questions about how this would be deployed. And same questions could be asked about the fact that if you increase that much electricity, you get into the conversation about how many large infrastructure projects can you actually put out, what are the holdups, and so on. And part of it may be about the modeling itself, of course, what it does cover, what it does not, and what needs to be improved for the projection to be realized. And it's not necessarily small things or very specific things. It can be a general question. So what kind of role can bioenergy play in a decarbonized future? So if the model has a lot of options, it may do a lot of things with bioenergy, and it raises its profile. And it may be just constrained on total availability, for instance, but what else, right? If you have a whole system to deploy, how do you think about it? We had a 2-year project at the Institut on bioenergy in Canada trying to answer the straightforward question of, what's the best use of biomass for decarbonization purposes? And the answer is, at a high level, is a bit disappointing, because the answer is it's complicated and it depends, right? So on many, many factors. So in other words, when we say that results should be treated with care, there's also reflection. It's not just a general statement. What do we mean by giving more care exactly? And a final strategic advantage that I wanted to point out when we rely on solid modeling is that it sharpens the distinction between short-term constraints and longer-term structural shifts. So that seems obvious, but when people look at charts, they tend to understand the result for 2050 the same way as they do for the 2030 result, which is, of course, incorrect. So if you're looking at a transformation that is going on at an insufficient pace at the moment, then you can ask questions about how do you change the rhythm? Is it incorrect or insufficient policy? Do you need to do anything else to accelerate it? And same line of thought when you look at something longer term, but that still survives a lot of sensitivity analysis, so that's very likely. You need a deep analysis of realism on the ground, right? So modeling for us in that context is much more than a technical tool, but it's really a core element for thinking about policy as well.
Merci, Simon. Finally, Edouard will present the M3 platform, a Canadian open source energy modeling initiative.
All right, my turn. Great, so today I want to talk about a new initiative we've been working with our colleague at UVic, CICIT. So it's called the Energy Policy Monitor. I'm pretty sure most of us knows about EMH, but just as a recap, so we are a consortium of Canadian university funded by NRCan mostly, and our job is to connect energy modeling with public policy. We have 3 priorities: open models and data, capacity building, and convening the community, just like we are doing today. So what is EPM, the Energy Policy Monitor? So basically, it's a project from Open Insight, a collaboration between CICIT, the University of Victoria, the EMH, and Macrocosm. It's a share framework with using common standard, open source commitments, publication process that govern every assessment from start to finish. Each partner has clear role in that new initiative. CICIT is basically is the academic partner. They build and run the models. Macrocosm bring the economic modeling layer. EMH provide the infrastructure, the data, and support to operate some of the model platform that we're going to present today in a minute. And basically, Open Insight is the umbrella that connect all of those together. So it's really a collaboration in action, and the goal is to provide independent, timely, credible assessment of Canadian energy and climate policy. It's independent because it relies on one methodology. Every policy, every jurisdiction, there's no advocacy here, no clients. The goal is really to put those policy on the public domain with real data. It's timely because we want to publish it in a week, not in months or year. And it should be credible because it's transparent and you can have access to the full audit trail of every public assessment. So the process itself, I won't go into much detail. There's really 5 phases. The policy is announced. Our team the team at CICIT or any other academic partner will review it and try to scope it within a 1 or 2 days time frame. They'll decide whether it's a policy that we need to assess. And then we encode this policy, and this is supported by a big database of assumption and data we've been building over the last few years. Then we model a couple of runs. There's some stakeholders involved in the review, and then we're going to publish it using a website, a Zenodo, and a two-pager. And everything is published at once, the code, the data sets, the assumptions, so every stakeholders are welcome to review and challenge some of those assumptions. So under the hood, there's this tool called M3 platform. You might have heard about it already. So EMH operates this platform with 3 layers, open data that is coming from coders. It's our open energy database. We have also an assumption database that is trying to convert those policies into constraints that can be modeled as well. This feeds into a suite of open source models, so Silver, Copper, SIMS, Message, eventually, hopefully, Unmerge and other tools as well. And finally, we have this visualization layer called IDEA, another open source tool to facilitate comparison and an assessment of results. The other trail is very important. We want to make sure that you have access to the brief using a DOI, the full result of data sets, the policy encoding sheets, and the actual code is published on GitHub. So there's no black box here. If you disagree with some of the assumptions, you are free to change them and rerun yourself, or work with any kind of stakeholders that might help you, including the EMH. And I just want to maybe say why this is important. So I think for this panel, for us at EMH, I think we were in a situation where modeling was very good, but it didn't land, right? It came too late. The timing was off. So I think that the decision here is to make sure we can streamline some of those policy assessments and be able to deliver in a timely manner some high-level results that will need to be improved and augmented over time. But the goal is to make it easy for stakeholders to look at policies and basically assess some of the results before it's too late. And the trust question is really real, right? So I don't think, and we don't think at EMH that modeling one model should rule them all, right? We need a diversity and variety of models to make different assessments. So this platform also aims to enable this multi-comparison of results and models. And our work as EMH is to convene the stakeholders group to make sure that we can operate this platform together. So we're launching this week, so feel free to visit the openinsight.ca website and visit EPM, which is for Energy Policy Monitor. We don't have real result there yet. We're going to launch our first set of results in a few weeks, but there's some mock-up example you can look at, and of course you can look at our models on that platform as well. So thank you so much. Please visit that, and if you have any questions during the break, happy to answer, and now we'll continue with some of the discussion with the panel. Thank you.
Merci, Edouard, and thank you again to all of our speakers. So what emerges from this presentation, I believe, is that open modeling is no longer only an academic exercise. Discussion is increasingly about institutional trust, policy relevance, and the infrastructure needed to support transparent decision-making. So I would like, therefore, to organize a discussion around a few themes: credibility, policy uptake, open versus proprietary approaches, and institutional gaps. So let's start with the first theme, trust and credibility, and I would like to ask Luciana the following question. So open models are increasingly visible in policy discussion, but trust may remain an issue. So in practice, what creates credibility with decision makers? Is it transparency of the code, quality of the data, validation against reality, institutional reputation? So please.
Thank you for the question. It's not. Can you hear me? Yes. Thank you for the question, Olivier. The experience I have in Europe is that the most important aspect for the credibility of open models is the validation against the real results. So I have been into discussions with the European Commission, in certain events where they really ask us, do you have any validation results that we are sure that these models really, they perform well and that we can trust the results they return, because the results, they will be used in very important decisions, in policy decisions, also into investments, like the example I gave for the OpenTYNDP. So yeah, the investments will be given to certain projects depending on the results of the study. So they really are interested in seeing that the model can return results which are valid in the real world. So I would say this is the most important aspect to be considered.
Thank you, Luciana. Has the US or Canadian experience differed from the European one? I don't know if any of you wants to.
Hello. I think, you know, in the US experience, or at least the experience that I've had, you know, I have heard this argument that open source tools are less credible than you know, proprietary tools, but I think that is only an argument to familiarity, not to the actual capability of the tools. And in the experience I had in Illinois, I got very few questions about the actual tool that we used to conduct the analysis. More so, and I think more important, is that the analysis was conducted by an institution with some reputation for rigor and scientific analyses. And then on top of that, I think it was also very useful to have a coalition of partners that adopted our findings and helped us get the message out about the work that we did. So I think that is a little bit different, but yeah. Yeah.
Edouard?
Yeah, sure. So I agree with both topic here. So validation and reputation are certainly the key. I would add, from our point of view, data quality is always an issue, right, when they challenge some of the underlying model results. So, you know, TSOs and utilities have access to different sets of data that we don't when we do open source modeling. So access to better data might, or to more open data might increase the trust as well, right? But that's a tough nut to crack, right? To have, I'm sure everybody in the room knows that. So I think to emphasize the data quality or try to have access to better set of data will certainly help the trust issue as well.
Simon, you want to further comment? No? Okay.
No comments.
Thanks. So let's then turn to the second theme, which is policy uptake. And I would like to first ask Samuel. So your Illinois case is a success story, but there are also situations where the modeling was solid, but yet the policy impact did not materialize. So have you seen such situations, and where does the process usually break down?
Have I seen situations where modeling was conducted and did not lead to policy uptake? Yes, I'd say that. I would say that is the more common situation than success stories. But I think this community and this room we're all working on sort of changing that narrative a bit. I do think that timing is really important. And I think that legibility is really important. So, you know, from my personal, if I were modeling for myself, I would always want to do all the sensitivities that I could, all of the uncertainty analysis that I could, but sometimes that does not translate well to policy, or it doesn't translate well to is more difficult to communicate the importance and the impact of those results. And I think legislators and also members of the public like to see confidence and certainty in answers. So I think that is, and that's how sort of the simplicity of the analysis that we did played a strong role as well, because it was extremely legible and digestible to the audience. So I think those are, let's say timing and digestibility are the two things that I would say are significant in this.
No, just want to say there's two mics also. Feel free to go to the mic if you want to ask any questions. We didn't mention that. It's my fault, so feel free to use the mic as well. But.
Yeah, and anyway, we'll have a Q&A session with the audience at the end as well. So any other panelists want to comment on this issue?
Yeah, I wanted to add to that. So I think we're looking at EMH right now is to involve policy analysts, policymakers, upfront, right, before the actual modeling exercise starts, so they are stakeholder in the whole process. So here I'm talking about policymaker, policy analyst, but actually any end user result, right, and yeah, those that's going to use the results. Basically, they need to be involved as soon as possible in the process to maybe inform the scenario, inform some of the assumption, help design the scope. If as modeler we just do that on our side of the room, right, and then we come back with our view of things, I think there's a chance that some of those results won't be accepted as easily as you involve them early in the process. So I think that's another thing we want to try at EMH, and I think it should be, a practice everywhere when we do open source modeling.
Thank you. Luciana or?
Yeah, just to combine actually two of the things you both mentioned, timing is really important here in this question. So if the modeling comes at the policy-making phase where you basically have this idea and you hire modelers to say, show me what my idea can do, it's not a bad question to ask, of course, but it's a leading question, right? So you get results and then maybe it's very likely that it confirms what you were hoping for, or at least give you a sense of what you can do. But if you're looking at modeling to do planning and exploration of different pathways or higher level things, then it's much more difficult, right? So the timing may be important. If the modeling needs to be open, then you also fall into not the trap, but the problem that you would need 800 different scenarios and so on, which you won't do, right? So it's a catch-22.
Luciana, you want to add to this?
No, I think I really agree with you, Edouard, on the aspect of involving the stakeholders. So the three examples I brought to you today that we are working at OET, it's the client, is the policymaker or the regulator, or so these entities are involved, or the transmission system operators. So they are involved in the process since the beginning. So they help us design a bit the model, and they help us define also the pathway we have to follow. So we really go on the direction of the results they need and they are looking for in the analysis. So it's been really important, and also for the credibility, because then they can really see that the open models, they can do what they're expecting to do, and this at the end helps us increase the credibility of open source models in the capabilities they can.
Thank you, Luciana. I would like now to move to the third theme, which is open versus proprietary approaches. So I would say in the past, many institutions would almost automatically default to proprietary tools, and I'm just wondering whether this is still justified today, and kind of follow-up question is, where do models still lag behind commercial platforms, and where do they now have a clear advantage? So I think the question is open to the whole panel. Who would like to start? You want to go?
Open versus commercial? I can try. You want to go? No, Sam, go.
Sure.
Can you just remind me, you're asking whether it is appropriate to continue using proprietary models versus open source models, or if there's...
So kind of the first question is whether it's still justified to have this preference nowadays for proprietary tools, and also in which aspect proprietary tools are better and which ones open tools would be better.
I might be a bit biased, but I don't think there are many
cases. We don't
cases.
Be biased, I guess, in this forum, right?
I don't think there are many cases actually where proprietary tools are functionally better. I think they are maybe superior in terms of data access because they purchase and or have licensed data from proprietary sources that we don't necessarily all have access to, and I think the main advantage they have is familiarity with policymakers, legislators, decision makers that maybe open source tools are building towards but haven't yet overcome fully.
So I agree with that. I think one place where open source might be better is definitively the contestability, or again, the transparency enable a wide variety of stakeholders to, again, challenge the underlying assumptions and mechanics behind the models. This has been said, I don't think the framing is right. It's not a competition. I think it should be something, again, that we're trying to do at the MH to enable model comparison. And again, I don't believe that one model can solve everything. So I think having a wide variety of model, commercial, non-commercial, looking at the same set of questions with their own angle and bias, and then put people in a room so they can agree or disagree on results makes a ton of sense. So I think we need both. But I do believe there's still a lack of trust and among certain open source models because they may be less mature, they didn't benefit from many years of investment, and data, it's always a key issue. I agree that data is often where commercial models perform better because they have access to larger database again. But in the end, we need, I think, both reality, and I would encourage any stakeholders to take those two approaches. It might add work, but it will provide extra value in my opinion.
Yeah, and I like this proposal of having this comparison of model, and I would like to salute your multi-model comparison forum that you put in place for Canada, which is a great venue for that. Any other further comment on this issue?
Yeah, I just wanted to complement that one thing that has been an advantage for open models, at least in Europe, is the fact that European money right now, like European commissions and the investments they making on research projects or on tools, they requesting right now for open source models. So really it's being like an opportunity to have investment and tool development, features development in such types of models, and also like I said before, working together with the stakeholders from the industry because of that push for open models and transparency from the policy makers and decision makers.
No further comments?
I see. I want to leave time for.
Aha, because you're awfully quiet. I'm surprised. Okay, so let's turn to the fourth and the last theme, which is institutional gap. And I would like to address first the question to Simon and Edouard. You both pointed to initiative creating bridges between modeling and policy. And if you want open modeling to become part of a routine policy infrastructure, what is still missing? What are the main bottlenecks? Would you say funding, institution, data access, training, political culture? Any other answer? All this answer?
Yeah, all of the above to a certain extent. It depends what kind of level, of course, the kind of questions that are asked. But I mean, I'll speak for the kind of work we do, higher level, economy-wide or province-wide kind of, trajectories. One thing about open modeling is that it may help, and it's kind of piggybacking on the answers to the previous question, but it's not just data access, it's access to the detailed results to provide a really thoughtful analysis. So in theory, open models are kind of solving that problem, because if you have free access to whatever you need in order to make your analysis, then that should yield more insightful policy recommendations. But at the same time, it doesn't substitute for the actual task of analyzing the data, which may take a while, and maybe it's a time frame you don't have at the policy level, right? So it's not a perfect solution, but this is where perhaps there's a lot of value that can be extracted. So, in my earlier answer, I was mentioning timing and saying if you bring in modeling too late in the policy elaboration process, then you have a few weeks to basically confirm what you've already decided, which is not that useful. But if you think about open modeling, in the spirit of the comparison of models, in that context, where it can come in and use the same set of hypotheses and try to push a little bit what the results are suggesting, then yes, that can be very helpful, and there should be more of that for sure.
Yeah. Yeah, totally agree with that. I think I see three gap, right, from an institutional point of view. So a commissioning culture. So in Europe, I guess You guys have I think you're lucky to get some money coming from the central government to commission, studies of scope on major policy with multiple stakeholders. I think this is starting in some provinces in Canada, but it's not as well established as it is in Europe, I think. I don't know about US, but in Europe it seems to be pretty common. We don't have also a lot of national coordination, so everybody knows in the room that every province have their own mechanism and institution in Canada, so it's very fragmented. So this national coordination, I think, lack in terms of modeling capacity as well, and this is where also EMH is trying to play a role. There's going to be an announcement from Prime Minister today about national electricity strategy that will, I think, talk about more coordination. So I think it's a good news. And the third issues is what we've been mentioning earlier. This collaboration between policymakers and modelers and industries and academic and consultant. Again, we're trying to play a small role in this, but I think to make this tools that every stakeholders work upon, we need to have those bridge built between those stakeholders. So that will be my take.
Any further comment on this theme? Samuel, Jana?
What about US? Is there a centralized, not now, but
US has hardly centralized anything. Every state is different. There are many layers of complexity and different institutions, different governing bodies, and navigating all of it is not an easy task. And it really, I think, supports the idea that one model can't do it all because there are just too many things to model that wouldn't fit in the scope of a single tool. It's a very complex landscape in the US.
What about Europe?
Yeah, I think it's true that in Europe there's a more coordination, and even though there's many actors and you have like always the national level of things and the European level of things, so they try to build a bit like processes that, one communicates with the other. For example, if you do like an European-wide study, you're going to use national input data for that. At least that's what we do in our projects. Maybe I think there's still a bit of a lack of trust, even though we get like this investments from European Commission projects, and we do getting more requests for open source models. There's still a bit of a lack of trust. Like I said, I've already talked to like European Commission people that said that we don't know if it's true or not, if it's good or not, if the results are valuable or not. Do you have comparisons with the real results? So I think there's still, I would say institutionally that's the main problem. Like NSOE, the entity that coordinates all the transmission system operators in Europe, they use Plexus for their adequacy research. And even though some TSOs in Europe, like Elia, the Belgian one, would say, oh, why don't you use open source? We use open source, it's good, it's transparent, it's customizable. You still have this partnerships and the data process and everything that goes through this proprietary tool, and then the trust, of course, it's harder to build for open source models. Then I think that will be the main question in Europe.
Thank you, Luciana. So it's now time to turn to the audience. We have a few minutes remaining to this panel, so feel free to ask any questions to our panelists, either technical questions or related to institutional and policy dimensions. So we have mics, and it would be nice also if you could identify yourself before asking the question. Thank you.
Hi, everyone. Okay, great. Hi, everyone. So I'm Vanessa Smeichel from EMH, and I have some questions from the Zoom, the online participants. So Hatem Hazidi has a question for Simon, and it's kind of a twofold question, so answer what comes to you first. How can numerical modeling be integrated into the bioenergy sector, particularly in applications such as renewable natural gas? Also, from a strategic perspective, how do you see numeric modeling contributing to the development and scaling of the bioenergy sector?
Okay. First part of the question I can't really answer in 2 minutes, but I'm happy to have the talk with the person, so please contact us. But for the second, I guess a little bit more high-level question, the short answer is in many ways, right? So I mentioned in my presentation the fact that bioenergy is this complicated, one big component that's very much underdeveloped in a lot of models we've seen, or at least in the scenarios that are put forward, and becomes this chunk, right? So there's electricity and then bioenergy, and then whatever questions are asked about the quantity, it's mostly about feedstock and where it comes from and so on. So the modeling that can jump into this and factor in local perspectives, and not just for the transport of feedstocks, but also synergies among the different usages. So, renewable natural gas may be one, but there's also the fact that bioenergy can do a lot of things, and then it becomes the same as hydrogen, right? It's not because you can do all these things that you should be doing them, right? So how do you compare them? And in the work I was referencing before, and I encourage the audience to look into, there is a grid that kind of compares all different criteria. So is it about energy efficiency that you're concerned? Is it about reducing greenhouse gas emissions? Is it about contributing to the energy mix and so on? So, long answer, still high level, but I'm happy to have a longer conversation.
Okay, next question.
Hi, thanks for the talk. Great points that you've raised. You mentioned proprietary versus open source models, and you talked about how proprietary models can provide support, can provide data sets as part of their contracting. I didn't hear any mention of the solver under the hood. When you're using an open source model, you still have to use a solver, and for large systems, sometimes you need proprietary solvers that have a licensing cost associated with it. For the places that have adopted open source models, are they using open source solvers? Can you speak to that a little bit?
Yeah, I can take this one. So yeah, in the studies we do, we try to use HICE as a solver. It depends, of course, on the scope and on the type. I think the complexity, that's the experience we have at OET, the complexity of the model you're solving, that's what would dictate if you need to spend money with the solver licenses. If the model takes too long, and depending on how many simulations you need to do, you might need to go for proprietary solver and then you have to pay for the license cost. We do like solver benchmarks at OET to calculate then to compare different solvers, especially open source solvers. But we will try to use really the HICE as the main solver for our models. I don't know what's your experience.
Yeah, I think you touched a very good point, right? If you have open source models, and solver needs to be, but it's less an open source discussion than an accessibility of model discussion. I don't want to say a buzzword here. I think AI and surrogate models might help also in the future to democratize part of the modeling works, but we'll always need to find an innovative solution. But if we see that more open source tools are used and the adoption rate is, I'm hopeful that there'll be alternative solution, but for now it could be a bottleneck. But the real bottleneck is also the expertise to operate those models, because even if those are not easy to operate, to be fair. So this is why I think there's a balance to get also how do you communicate results, to make those results accessible, digestible, using some kind of interactive charts and visualization platform that maybe most end user will like. They won't run the model themselves, but they want to be able access to the data set. But those are complex issues. I totally agree with you.
No more comments from the panel? All right, so next question, please.
Thank you for your perspective on open source modeling versus in-house modeling that's not open to all. I have a couple of thoughts or questions on that. When we talk about open source modeling, who are the users of the open source modeling? What are the barriers? And are they being used in the policy development? What is the pattern? And then the other question is on model validation. So what kind of validation we are talking about? Are we talking about, because when we run the models, the so-called energy model or these policy models, we're talking about something like in the future, and it's going to happen, and it is very difficult to validate those models in thing. Second thing is that even when we do simulation using models, we do simulation with specific policy, like for example, clean fuel standard and so on. But, and then how do I validate that with respect to the realities, what happened? While realities are a complex thing, there are many events happening at the same time. So isolating them, those things, and pinpointing the real impact of a specific policy, tracking it down is very tedious and difficult. So you need that time probably or econometric or empirical methods to validate this. So are we talking about what kind of validation we're talking about? And has there been some examples the panelists can highlight us to get a good idea? Thank you.
Well,
yeah. So for the first question about the use of the open models into real context, so I brought like 3 examples. So in Europe, we are using them for real decisions. For example, the Walloon government, we did a project there where we developed a tool to help them define their climate goals, really in the policy context with the government. Also, the flexibility needs assessment, which is for the European regulator to do a study on the flexibility needs of Europe, the whole of Europe, with the data of the whole of Europe, everything involved, and a specific customized model. I cannot give details here, but yeah, it's really to be taken for decision making. So yes, it's been applied in real context, and for the validation, that's a very, very good question. What my experience is that we're going to try to use to validate, for example, market model simulations for estimating prices in the future. We use like past data on the markets, and then we run the models with this past data, and we compare, for example, the prices or the dispatches to make sure that the model can simulate the market behavior, because yeah, that's how Europe, the market is in Europe, and we use these market models and these dispatch models, for example, economic dispatch models, to simulate how the needs of energy and in the future, and then we use the past data both on the inputs and the outputs to validate the model. So that's the experience we have in terms of validation. I don't know if you have other validation methods that you use.
Another
just
answer?
Yeah, very quickly. So this is a very interesting topic, right? Validation is a field by itself. There's different ways to do that. Luciana mentioned one of those. The other one is, I believe in modeling comparison somehow when you benchmarks against other groups, other bias, because again, the role of model is not to predict the future, is to assess possible scenarios and what they mean. So I think we're not necessarily always looking, if you see a models with 5 digits precision, I don't think that can happen, right? We need to have some ballpark results that give us some clear orientation and direction. So I think comparison is a good way to validate. But then you need to validate the underlying data, the assumptions, the mathematical optimization mechanism behind it as well. So there's many layers to that, but that's a very valid question.
So we are at the end of this panel. Let's again give a round of applause to our panelists, Luciana, Samuel, Simon, and Edouard.